Hello everyone, welcome to the Espressif Developers Conference 2022. I am Hrishikesh, and in today's session, we'll talk about Matter, a new smart home ecosystem protocol. We'll look into what Matter means to us, its advantages, and deep dive into its features. After that, we'll talk about Espressif solutions for Matter. So now, let us take a look at the agenda. First, we'll have the introduction to Matter. Then we'll talk about the Matter data model. After that, we'll talk about commissioning. Commissioning is the process by which a Matter device gets added into the Matter network. Post that, we'll talk about multi-admin. Multi-admin is the way through which a single device can be a part of multiple Matter ecosystems, in a way fabrics at the same time. Then we'll talk about device-to-device automations, an interesting concept in Matter that facilitates seamless communication between devices. After that, we'll talk about OTA firmware upgrades for Matter. This will be followed by bridges for non-Matter devices. And finally, we'll talk about Espressif solutions for Matter. So, let's get going. Matter, previously Project Chip or Connected Home over IP, is a new working group within the Connectivity Standards Alliance. This new and royalty-free standard aims at creating more compatibility between the devices in the smart home. Matter is a unified framework for connected things. The Alliance has collaborated with the industry leaders for the implementation and the development of the spec. Matter is an open, secure, and reliable protocol. It seamlessly integrates with all the ecosystems that are available. Now, let us take a look at the protocol stack diagram of Matter. As can be seen, Matter is an application layer protocol for the local network. It runs on both TCP as well as UDP. For the current v1.0 release of Matter, only UDP is supported. Matter is IP-based, typically IPv6. Currently, it works on Ethernet, Wi-Fi, and Thread. Bluetooth Low Energy is used for commissioning or setup. Now let us take a look at what Matter means to us. First, for the end users. No more silos. Gone are the days that a vendor-specific app was required to control a vendor-specific device. With Matter, any Matter-enabled app can control any Matter-enabled device. Furthermore, companies like Google, Apple, Amazon, and Samsung have already committed to Matter, which means that their devices would support Matter out of the box. This implies that you might not even require a separate phone app to control a Matter device. Your mobile phones or your voice assistants can natively do it for you. More automations. Matter provides a seamless way to facilitate communication between devices in the same Matter network. For example, if you have a light switch and a light that are into the same Matter network, they can communicate with each other. Multiple transports. Matter facilitates multiple transports like Wi-Fi, Ethernet, and Thread. For transports that are not in the Matter framework, those are facilitated through the Matter bridges. Better security. The Matter specification has baked-in secure features. Those are reviewed and approved by the best in the tech industry. This implies that the Matter devices that will be certified are better secure and as they are based on well-reviewed and better specifications. Now, let us see what Matter means to the device makers. The advantages for the end users apply to the customers of these device makers. Apart from that, the other advantages are ease of development. Now, the device makers won't have to go through the pain of supporting and certifying multiple ecosystems. This will lead to reduced overhead of engineering effort, cost, and time, thus leading to faster products. Power of the open. The Matter implementation is in the open source. It supports a variety of vendors. It means you can prototype, validate, and productize your devices in the shortest possible time. Device-to-device automations. If you are a device maker who creates products like switches and sensors that need to work in conjunction with other devices, then Matter is like a good news for you. With Matter, you don't have to worry about what will the customers tie the output of your devices to. It will be taken care by the Matter protocol. Now, let us take a look at the Matter data model. Data model is the way in which the data is represented. The following are the elements of the Matter data model. First is the Matter node. A node is an addressable entity that has the Matter protocol stack running. A node has multiple endpoints. Consider endpoint like a virtual device. The Matter specification has combined together a common functionality into something called as device types. Endpoints are further divided into clusters. Clusters represent a common functionality that can be presented in a reusable way. Clusters can be server clusters or client clusters. Server clusters have attributes and client clusters operate on them. For any kind of communication between two Matter devices, it always happens through the clusters, the server cluster and the corresponding client cluster. Clusters have attributes, commands, and events. Attributes are entities that can be read or written to. Attributes are volatile or non-volatile. Attributes can be read only or read and write. Commands. Commands invoke a specific behavior on the cluster. Commands can be like read, write, subscribe, invoke. Events. Events indicate a change or an update in the system. Now let us take an example so that the data model is more clearer. The diagram shows a luminaire node that has a dimmable light and an on-off light. As can be seen, on the top, there is endpoint 0. Endpoint 0 is a reserved endpoint, which is the root node device type. It has the functionality that is applicable to the entire node. It includes clusters like ACL, commissioning, basic information, and OTA. In the center is the endpoint 1. It is the application device type, which is the dimmable light in this case. It has two clusters, the on-off cluster that has attribute on-off and commands like on, off, and toggle, and a level control cluster that has current level attribute and command like move to level. At the bottom, there is endpoint 2, which has the on-off light device type. Again, it has the on-off server cluster with attribute on-off and commands like on, off, and toggle. Let us now take a look at the commissioning process. Commissioning is the process by which a device gets added into the Matter network. It starts when the device announces its capability over BLE. If the device has IP connectivity, it does so over MDNS. The commissioner then scans a QR code on the device and gets the setup passcode and other metadata. This setup passcode is used to establish a secure session called as PACE. PACE is based on SPAKE2 plus protocol. The subsequent messages are now secured with PACE. The next step is device attestation. Device attestation is the way through which the commissioner validates that the device is a valid or legitimate Matter device. Once the device attestation is complete, the next step is operational credentials. Operational credential involves the commissioner installing an operational certificate onto the device. This operational certificate has an entity called as node ID that defines uniqueness of a device in the Matter network. All the Matter devices that share the same root of trust are a part of the same Matter fabric. The next thing is access control. Access control defines who controls what. There are different privileges of access control defined, like view, operate, manage, and administer. The device is then installed with the appropriate access privileges. The next part is network commissioning. This step involves giving IP connectivity to the device. If it is a Wi-Fi device, it is installed with the details about the Wi-Fi network. If it is a thread device, it is installed with the details related to the thread network. Once the device gets IP connectivity, it starts operational advertisement over the IP network. The commissioner then discovers the device on the IP network and establishes a secure session called as case. The node operational certificates that are installed in the operational credential step are used for this case establishment. This is based on the Sigma protocol. After that, all the messages that are exchanged between the two devices are secured with case. With this, the commissioning is complete. Let us see a demo video of the commissioning process. With ESP Launchpad, you can easily try out Matter on Espressif SoCs without having to do any kind of setup or installation. Here it goes. Now, let us take a look at a multi-admin feature. Through multi-admin, a device can be a part of multiple ecosystems or matter fabrics at the same time. As can be seen in the diagram, there is a light bulb at the center, which is already a part of two ecosystems or matter networks. Ecosystem A from organization 1, seen in green, and ecosystem B from organization 2, seen in red. As you can see, the light bulb has identity XYZ in the ecosystem A, whereas it has identity PQR in the ecosystem B. As a result, the iPhone and the smart wall switch on the ecosystem A can control the light, while the voice assistant in the ecosystem B can control the light simultaneously. The next question is, how is this facilitated? So once the device gets commissioned for the first time, the current administrator opens a commissioning window and the next administrator can commission the device into its network. The total number of node IDs on the device is equivalent to the total number of matter fabrics that the device supports. Now, let us take a look at an important or an interesting concept in Matter, which is device to device automations. Matter facilitates communication between devices without having to go through a cloud, a phone app, or a skill. Let us take an example for that. As you can see in the diagram, on the right hand side, there is a light. At the center, there is a switch. And on the left hand side, there is a phone app or the commissioner. The light has the on-off server, whereas the switch has the on-off client. Once both of them are commissioned into the same Matter network, the commissioner can bind the light to the switch. In short, now the switch knows the address of the light. The switch can then discover the light and establish a case session with it. After that, any action on the switch is reflected onto the light. This is a part of the synchronous control for the device-to-device automations. There is another way through the asynchronous notifications. Let us take an example for that. On the right-hand side, you can see an occupancy sensor that has the occupancy sensing server. In the center, there is a thermostat that has the occupancy sensing client. On the left-hand side is the commissioner. The commissioner first commissions both the thermostat and the sensor into the same Matter network. Once that is done, it can bind the sensor with the thermostat. After that, the thermostat establishes a secure session, that is case, with the sensor. Thermostat can then subscribe to attributes on the sensor, say the occupancy attribute in this case. Then, when there is any change in the occupancy attribute, the same is reflected or reported to the thermostat. This is nothing but subscribing to attributes. Similarly, subscribing to events is also possible. When a particular event occurs, the same is reported to the client. With this, I'll pass on the mic to my colleague Shubham, who will talk about OTA and bridges in Matter. Thank you.
Hello everyone, I'm Shubham and now we'll talk about Matter OTA functionality. Majority of the IoT device requires security as well as feature upgrades in their lifetime. There shall be some way to upgrade an IoT device. Matter standards has already defined a way to upgrade a device. It contains a node which implements a device type called OTA requester. It contains a node which implements a device type called OTA provider and distributed compliance ledger. The flow is like an authorized user uploads an OTA image to distributed compliance ledger. Then OTA provider downloads the OTA image from distributed compliance ledger and forwards it to the OTA requester using Matter protocol. Distributed compliance ledger is a distributed information system which contains information related to the vendors, certification related details, and OTA URLs. Now, let's talk about Matter Bridge for non-Matter devices. Matter Bridge enables Matter devices to communicate with non-Matter devices. If we look at this example, this Matter controller app can communicate with Zigbee Lite. Matter Bridge translates between the Matter protocol and a Zigbee protocol. Matter Bridge also forwards the commands received from a Matter node to a non-Matter node. Also, Matter Bridge exposes the Zigbee lights to the Matter nodes using its data model. Now, let's look at the data model of Matter Bridge. If you look at the topmost block, that is endpoint 0, it contains a descriptor cluster with the parts list that contains bridged as well as non-bridged devices. Additionally, it contains an endpoint which has a device type aggregator. The parts list of that node, that endpoint contains the bridge nodes. In this diagram, if you look at the green block, its parts list contain endpoint 11 and endpoint 12. So the last two blocks are the endpoint 11 and endpoint 12. If you, that contains, so let's look at endpoint 11. It contains the descriptor cluster and its descriptor cluster contains a device type list. So in there, the endpoint 11 is an extended color light and endpoint 12 is a dimmable light. So that's how a matter bridge exposes the non-matter devices to a matter nodes. Along with the descriptor cluster, endpoint 11 and endpoint 12 has additionally bridged device information cluster, which contains basic details like vendor ID, product ID, its software version, and some more details. Now, I'll hand over mic to my colleague Shu. He'll talk about Espressif's solution for Matter.
Hi everyone, this is Chen Shu from Espressif. As Hrishikesh and Shubham shared in the previous session, there are so many wonderful features and advantages in MET protocol. Now, let me talk about the Espressif's one-stop MET solutions. I will introduce Espressif's MET platform solutions and Espressif's SDK for MET, as well as some additional services that we provide to our customer, which would accelerate our customers' MET products' time to market. Before we look into the platform solutions, I'd like to share a typical MET topology in the real life. From the topology, we can see a Wi-Fi light, a Wi-Fi switch, and a thread thermostat. A thread border router is required to connect the Wi-Fi and thread network on the IP layer. All these devices could communicate with each other within the local network. No need to go through an app or cloud. On the right side, there is a MET bridge device. Bridge is one of the useful features in MET, which allows the use of non-MET devices in a MET fabric. For instance, a MET Wi-Fi switch controls a built-in mesh light, or a MET thermostat subscribes the temperature data of a Zigbee sensor. Espressif provides customers with platforms that cover all these MET devices. Our Wi-Fi-enabled SoCs and modules, such as ESP32, ESP32C, ESP32S series, all can be used to build a MET Wi-Fi device. Our newly announced ESP32H SoC and modules integrated with 15.4 can be used to build MET thread device. By efficiently combining Espressif's Wi-Fi and thread technology, the thread border router can be built to connect the Wi-Fi and thread network. With the same hardware, a MET Zigbee bridge device can also be built to bridge Zigbee devices to the MET fabric. Finally, a MET built-in mesh bridge can be built on a single ESP SoC with both Wi-Fi and built-in interfaces. Now let's come to the software part. Espressif's SDK for MET is built on top of ESP IDF and the open source connected home IP SDK. ESP IDF is Espressif's official IoT framework, integrated with rich, commonly used features and components to build AIoT products, which already powers millions of connected devices worldwide. Beyond the open source connected home IP SDK, Espressif SDK for MET provides a bunch of features and tools for MET productization. The SDK and docs are all now available on GitHub. The SDK provides simplified data model APIs. The developers can use these APIs to define their own MET devices quickly. For example, if you want to define a standard MET color temperature light, you can achieve that in a few lines of code, just like this. Of course, you can also add optional or custom features like clusters attributes easily with the APIs. The SDK also provides rich device types, commonly used drivers, and production-ready examples. We also support the mechanism to run MET and other applications together on your device. So you can add MET feature support to your existing products, which already run some other applications. We also provide rich tools and utilities for manufacturing and mass production. This is an often overlooked but a critical component of the device development lifecycle. By using Espressif SDK for MET, We aim to further simplify and accelerate the development process of Matter products. Now here comes the ESP thread router solution. The SDK is built on top of ESP IDF and OpenThread. It's RTOS-based, so very cost-effective comparing to the Linux-based router solutions. It's compliant with the latest Thread 1.3 and supports Matter application. Also, we provide ESP Thread router dev kit and reference design, which integrates the RCP update and IF coexistence design. You can now access the SDK from GitHub. Besides the platform solutions and software SDK, we also provide some additional services to our customers. For example, the certification service. The CSA Matter Working Group defines very strict and detailed certification program, which could make sure that Matter products from various device makers could work together securely and seamlessly. Espressif joins the certification program from the very beginning. We can provide our customers the certification services and support them whenever necessary. Also, Matter requires per device unique certificates and a secure manufacturing process. Espressif will provide the pre-provisioning service for Matter, where we will ensure that the modules are programmed securely and the security features are enabled before shipping them out. Espressif will also optionally offer baked-in DACs in modules, so our customers don't need to worry about the PKI service or DAC generation. Furthermore, we will introduce special modules and product-level firmware for standard Matter devices. Without writing any code, the licensed customers can build standard Matter devices with a simple configuration, which greatly reduces R&D investment. By the end, let's watch a demo video that showcases Espressif's Matter solutions. Thank you.
Hi everyone, I'm Kedar, Senior Director of Engineering for Espressif Systems. At Espressif Systems, we build connectivity solutions for Wi-Fi, Bluetooth, and 802.15.4 based devices. Here we have a demonstration which shows the typical classes of devices that are supported by Matter. We'll talk about a Wi-Fi end device, a Thread end device, and the border router, a Matter gateway that bridges to Zigbee device, and a Matter-based controller. As you can see here, we have assembled a bunch of devices. They have already been commissioned into a Matter fabric, and we have defined device bindings so that the appropriate device controls the right devices. Let's get on with the demo. First, we'll talk about Wi-Fi based end devices. Here you see a Wi-Fi switch that is going to control this fan, which is also a Wi-Fi fan. When I switch on this device, as you can see that the fan has turned on, and when I press it back again, the fan has turned off. As you might notice, this communication has happened over Matter Wi-Fi. Now we'll look at this part of the demo. Here we have a thread-based light and a Wi-Fi based occupancy sensor. Connecting them together is also a thread border router that will ensure that the thread and Wi-Fi sites can talk with each other. As I make the movement in front of the occupancy sensor, the light comes on. The Wi-Fi device in this case has connected to the thread end device and operated upon it. Moving on, we'll now look at the Matter bridge. Here we have a door sensor, which is a typical off-the-shelf Zigbee door sensor. It is part of the Matter network through this Matter bridge. And in this case, it will now be